Okay, let's continue.
Pivot. Now let's do the pivoting. Okay, the elimination. So that is going to be this our new pivot. Okay, so a let's not forget this is row 2 and then this is row 4. Okay, good. So a2 a2 1, just a minute. So a2 2 new is going to be what? 2 minus what? Leading coefficient 2 over what? Pivot, which is -2. Okay, times value on top, which is -2, -2. So -2 cancels out this, and then 2 minus 2 is equal to 0. Next one is a2 3 new is what? Is -2 minus -2 over 2 over -2 is -1. So we use that. So -1 times what? -1 times 2. Okay. Yeah, so we have this is going to be +2 here, and this -2, so we have 0. Then we have a24 new is equals to, we have 1. Okay, minus 1, -1. Okay, times what? Times 4, which will give us 1 plus 4, which is equals to what? Equals 5. Okay, then next one will be B2 new is what? -3 minus what? -1. Okay, times 8. Okay, which will give us what? +8 here, -3, which is going to be 5, +5. Okay, so that's it for the next row. Okay, good. Then for this last row here, we're using the same, okay, the same pivot. So that gives us, we have a4 2 new. Okay, a4 2 new is equals to 2 minus, we have 2 over -2. Okay, times -2. Okay, which will be equal to 0. Then we have a4 3 new will give us, we got that is 1 minus 1. Okay, times what? Times 2. So this gives us +2. That's +2 plus 1 is 3. The next one we have from a4 new will give us 8 minus -1 minus 1. Okay, times 4. So we have +4. 8 plus 4 should give us 12. Then finally we have B4. So B4 new gives us, we have 10 minus -1 -1 times, okay, times 8, which gives us +8 plus 10 is 18. Okay, good. So we can then populate our matrix, okay, with the new estimated values. Okay, to have this matrix. Let me clear the screen. Okay, so this gives us the matrix as we see over here. Okay, so as explained last week, okay, this time we have an echelon. Um, we have an upper triangular matrix. It's just a matter of interchanging row 3. Sorry, there should be row 2 and row 4. Okay, so by interchanging row 2 and row 4, we have our upper triangular matrix. Okay, then we can rewrite the matrix, okay, in this form as a system of equations, and then use backward substitution to solve for it. Clearly, we can see that Z is equals to 1. Okay, Z is equals to 1. Okay, and 1Z is equals to 1. Then it means we have 12 times 1, which is 12. Okay, we take to the other side. That should give us what? That should give us 6. And then 3y is equals to 6, which implies that y, okay, it implies that y is equals to 2. Very well. So we have z equals to 1, y equals to 2. So that will give us 4 plus 4, which is equals to what? Which is equal to 8. Okay. That gives us 8. Okay. Let's be very sure of this first. Okay, so this 12, 6, that's 2. This is 4. Yeah, this is 4. This is also going to be 4. Okay, so it goes to the other side. That will be 0. X is going to be 0. So we have x equals to 0. And finally, we put that here. So x is 0. Y is 2. Z is 1. Okay, so we have 2 plus 1 is 3. We cross over, that will be 4. Okay, so 2w is equals to 4, which implies that w is also equals to what? It's also equal to 2. Okay, so that gives us the solution of the system using what? The scaled pivoting G method. Okay, any questions? Any questions so far? Any questions so far? Is Bami delay on this platform? To the solution of the system.
Okay, so we want to look at the next method, elimination technique. Okay, so you listen to that too very carefully. If you have any questions, you can ask me.
A very simple method. Okay, and the good thing about this method is if it's well done, then by the time you finish the transformation, you have your determinant, your inverse of the matrix, in addition to the solution of the system. Okay, so basically Gauss-Jordan is a technique which will convert, okay, the system as an augmented system with the identity element into the form determinant, okay, of the matrix A here, okay, times the identity solution and inverse of the matrix A. Okay, where I is identity and identity matrix and A inverse is the inverse and B is the solution of the system. Okay, and here we are using the factorization method together with the normal Gaussian elimination approach. Okay, good. So what we do first is, if you're given any system of equation, what you do is you rewrite the augmented form, okay, which is a normal A, okay, A, B form. Then you add, okay, the identity matrix to the system. Good. Then what you do is you are now going to use GE and factorization to change the first matrix into an identity matrix. Okay, so you transform the first matrix into an identity matrix. By the time you obtain identity matrix, you have your solution matrix at this point. Okay, you should have your solution matrix. And then the last matrix here is going to be the inverse of the matrix A. And the factorized coefficient here is the determinant. Okay, the product of the factors gives you the determinant of the matrix A. Good. That's the lovely thing about this technique. Okay, so let's solve an example. Just take note of the transformation whilst we solve an example. Good. So as our first example, we want to try this simple 2x2 system. Want to try this simple 2x2 system. Just study the system a bit. Or just look at it briefly and then I'll do the explanation. Give me a minute. System of equation, regardless of the dimension of the system. Okay, just write in the form of the augmented matrix with the identity. Okay, so that is A, B, and then we have the identity system here. Okay, yeah, and like we said, the objective is to convert A into A into identity matrix. Okay, good. And to do that, we employ the Gaussian elimination as well as factorization. Okay, so step one, what do you, yeah, and let me say, in reducing A to identity matrix, then it means that we are supposed to obtain the matrix 1, 1, 0, 0, okay? In the first component here, okay? That is what we mean by changing A to what? To I, okay? Good. So if that is the case, then it means that the elements on the diagonal, whatever be the case, we'll have to do some factorization to get them into the form of 1, right? And then once we've obtained 1 here, we can use the 1 to, eliminate, okay, whatever value we have in the other diagonal here. You understand? So we can use first first we can use this one here to eliminate this to 0. Then we factorize and then make this also 1. Okay, and then we can use that also to reduce whatever value we have here to 0. Okay, using the Gaussian elimination method. Okay, which is very very simple. Good. So let's give it a try. Good. So step 1, we would like this A11 to become 1. Okay, and to make that 1, it means we have to factorize. So the operation we're going to have here is to factorize 3 from what? From row 1. We're going to factorize 3 from row 1. I'm going to zoom in so that we can follow step by step. Okay, so the first step is to factorize 3 from the first row. Okay, and once we do that, okay, we're going to have 3 outside the brackets. Okay, so this is what we're going to have as a result. Okay, so we have 3 outside the bracket. Okay, and then within you have 3 over 3, 2 over 3, 13 over 3, 1 over 3, 0 over 3. Okay, good. Then you simplify that. Okay, so when we simplify, we're going to get 3, 1, 2 over 3, 13 over 3, 1 over 3, and 0. Okay, and then once we obtain it, like we said, the next thing to do is to reduce this to 0. Okay, this 4 must go to 0. Okay, so we just employ either the pivoting or the G method, okay, for reduction. And in doing so, you can have the operation, okay, row 2 minus 4 times of row 1. Okay, row 2 minus 4 times of row 1. We want to eliminate this. We want to make it 0. So if we have the linear combination 4 minus 4 times 1, we're going to get this to be 0. Okay, so that is why we have this operation here. Or like I said, you could have used a pivoting. If you're using pivoting, this is your pivot. Okay, so then it's going to be what? Then the operation is going to be what? A21. Okay, A21 new is equals to minus what? A21 new is equals to what? A21. Okay, which is no need for formulas. Let me just write. This will be 4 minus what? Your multiplier, which is 4 over 1. Okay, 4 over 1 times 1. 4 over 1 times what? Times 1, which is basically the same as in the case of the G. Okay, good. So which will give you 0. Okay, the next one remains the same. So A22 new will be what? 3 minus 4. Okay, 3 minus 4 times what? Times 2 over 3. Okay, good. Which will give you 8 over 3. And here we have 9 over 3. So 9 over 3, this will be 9 over 3 minus what? Minus 8. Okay, which will give us 1 over 3. Okay, good. Then you do same across the row. Okay, you do same across the row till you get to the last value. Don't forget. Okay, good. So once you do this calculation, okay, good, we'll come to this point. Okay, so we have 1. Just a minute. Okay, so you have 0, 1 over 3. You have 2 over 3, negative 1 4/3, and 1. Then, like we said, the objective is to have our diagonals to be 1 and 1, okay? So, which means that we need to factorize this also to become 1. Yeah, so you bring out 1/3, okay? Yeah, so we factorize 1/3 as the next um, operation. Okay, so that is going to be the next operation is going to be what? We factorize what? 1/3 from what? From row 2. Okay, we're going to factorize 1/3 from row 2, and then once we do that, okay, this is what we're going to get. Yeah, this is what we're going to get. Okay, so 1/3 from row 2 give us this side to be 1. 1/3 means you're actually going to multiply through by 3. Okay, so you multiply here by 3. Once we have 1/3 out, then you are multiplying through the row by 3. So we have 3 times 1/3, 1. 2/3 times 3 will give us what? 2. Negative 4/3 times 3 will give us negative 4. And then 1 times 3 will give you what? 3. Okay, then it's very clear that the next operation will be to convert this to 0. We want to eliminate this to 0 or put it to 0. Okay, and the only way we can do that is to use this diagonal. Okay, this diagonal value. Okay, and once again, that will be based on a G approach. Okay, good. So the next operation we're going to conduct will be what? Will be R1. Okay, row 1 minus 2 times R2/3. Okay, yeah, so once you multiply row 2 by 2/3, and you have the linear combination of row 1 and then minus 2/3 times of R2. Okay, we should get the operation, this operation here. Okay, we're going to get um, your 1/3 should still be here. Okay, don't forget. So we should get 1, 1, 0, 0. And once we do these other calculations too, okay, you should get here to be what? To be 3. Yeah, for those of you who be wondering, okay, so this is R1 is what? 13/3, okay, minus 2/3 times R2. This is R2, which is 2. Okay, so that's 2. Okay, so that gives us 13/3 minus what? Minus 4/3. Okay, LCM gives you what? LCM gives you 3. Okay, 13 minus 4 is what? 9. Okay, which
Okay, just a minute. Let me play the remaining side. What is this copy saying? You have another class at what time? 6 o'clock? But on the time, on your timetable, your normal class should be from 5:30 to 7:30. So why do you have another class at 6? On the school time.
It was 5:20 by the lecturer.
Yeah, so you
Gave us 5:20 by the lecturer.
yeah, so
The class at 6. So
like we said,
it cannot be 5:20. Your main timetable mass 201 is from 5:30 to 7:30. So how come you have another lecture at 5:20 to whatever time? I don't understand you. Unless you tell me the timetable has changed. But per my information, there has not been any change.
Mass 201 is 7:40 to 9:45.
Oh, really? Okay.
Yeah.
Okay. I see. Okay, I see. I think I've made a mix up. So 201 should have been the first class instead. Okay.
No, 201 is the second class rather.
Second class. Oh, so I should have been teaching 202 now. Not.
Yes, please.
Oh, I should have